Hi everyone, let's solve this problem linked list in a binary tree. So the problem statement says we are given this binary tree, the root of this binary tree and the head of a linked list, for example 4 to 8. We need to tell whether this linked list exists in this tree or not. So we can solve this problem recursively and iteratively both. So the idea is we'll see each node and check if its value match with head, right? If it match, oh, there is an event, like the event is okay, my head of the list is matching with my current node. So let's check whether entire list match there or not. So let's write it recursively. I think things will get more clear. The whole idea of this concept is, event trigger. We need to process the event which is triggered, which means the head of list matched with this node. So let's jump to the code. I say, okay, if there is no head, it means okay, I already have match because there was nothing to match. It will match with none node. So I say, okay, yes, it was there. But if there is no root, it means it can't match with anything, so I return false. Otherwise, all I say is if head.val is equals to root.val, right? If the values match here, all I need to say is okay, check this event processing, right? Process this event. I say self.process event, right? Or let's call it search. Let's call it now search it. Like this is our event, which we need to search, which we can process by searching the node. I say okay, search this guy at this node, right? And if status is true, which means the search became fine, I found that list, I'll return true. Otherwise, I'll return is subpath from head. I need to search in root.left, or I'm searching both the side. If root.left gave me bad answer, I'll go to right? So if anything gives me answer, I'm fine with that. So let's do this search function, right? So for that I say okay, let's write this search function. Let's get rid of this, we don't need that. I think it's good. Okay, so I need to search my head and root. I say okay, again I say okay, if there is no head, I'll return true. If there is no root, I'll return false. Or also let's say if not root, or root.val is not equals to head.val again. Otherwise the both values match. All I need to do is return. So this is just recursive search I'm writing, so there's nothing fancy here. I'm searching my head.next. It should be there, right? Head.next should be either in root.left or it should be in root.right. Right? This is some sort of DFS search where we have to search it. Like if I find the head, it should be, its next should be either in left or right? So let's see guys if it works. Let's try submitting it. Cool, it does. So let's jump to the iterative solution. So in the iterative solution, all we need to do is we need to replicate this function call whatever was happening in the stack. So let's jump to this in an iterative manner. So this part we need, right? We have to search whenever we found the value. So we don't need this code. So let's write a stack. I say okay, my stack should contain only the root value now, right? So I just have checked the base cases, and now while I have some element inside the stack, right, I'll pop it, right? I'll pop this element, and now if cur.val matches the head.val, all I need to know is tell me the status. Tell me the status if my head node, like the entire list, is present there or not, right? So I say okay, if the entire list is present starting at the cur node. So this is head and this is cur. So if status is true, I'll return true. Otherwise, once my entire loop is finished, I'll return false, right? This is a setup. But now let's say if this value didn't match, right? All I need to do is I need to process my right child and the left child both, right? Because it's a stack, we need to work with the right child first. So I say okay, if cur.right is there, I need to push this to stack because it has to be processed. I say okay, stack dot append cur.right, and similarly if cur.left exists, I'll append cur.left. You can do it with VFS and all those kind of stuff, right? So it's just that you have to iterate the entire tree and see where the list exists. So let's see guys if it works. Okay, let's submit it. Awesome, it does. See you guys in next video.